Right. Y0. Okay, so you have to use Euler's method here to solve this. Yeah. Right. So your initial point is your x0, y0. So x0 equals 0 and y0 equals 1. Yeah. And your h is 0.1. The step size of your steps is 0.1.
Right.
Makes sense? And so now you can figure out using Euler's formula, which is, let's write Euler's formula, y of I plus 1 is equal to y of I plus f, is basically the derivative evaluated at xi, yi of your initial point times step size h. So that immediately means I can go ahead and figure out my y1. So y1 will be y initial, which is 1, right? Plus f of x0, y0 times h. So that's 1 plus, you substitute x0, y0 in the derivative. So you get 1e to the minus 1 times h, which is 0.1. So you get 1 plus 0.1 over e. And now, as you know, x, the second x.
But wouldn't it be 1 plus 1 times e to the 0?
Oh yeah, sorry, e to the 0. You're right, x0 is 0. So times 0.1, so that's just 1, 0.1 plus 1 is 1.1. Okay. And you can always find your next x by doing the initial x plus I plus 1, or maybe another less confusing way to write it is xi is your x0 plus ih. So that's 0 plus, so if I'm finding x1, it's x0, which is 0, plus 1 times 0.1. So the next x is 0.1. And from that, I could find y2. So y2 will be 1.1 plus the derivative evaluated at x1 and y1. So that's 1.1 e to the minus 0.1. So this becomes 1.1 plus 1.1 over e to the 0.1. And if you use a calculator, we get 2.09532. And from there, we can now find x2. So that's your x1, which is 0.1, plus 2 times 0.1. Okay. So that's 0.1, so that's 0.3. Wait, I meant 0 plus IH. 0 plus, so 0.2. And then Y3 will be Y2, which is 2.09532 plus the derivative. Oops, I forgot to multiply this by h, I think, here. Yeah, this is 0.1. So this answer here is off. Okay. So this is plus 1.1. So we get 1.19953. So here we could do that plus the value of the derivative, which is f of xi, which is, so this guy here, so f x y, in this case, just to write it here explicitly, is y e to the minus x. So this becomes 1.19953 e to the x2, which is negative 0.2 times h, which is 0.1. So we get plus times e. So the next one is 1.29774. And now we can find x3. So we get 0 plus 3 times 0.1, so it will be 0.3. Right? And y4 will just be the original y, y3. Are you stuck somewhere? You have a question?
I was right somewhere.
What did you get? Are you using your calculator?
I'm gonna do that.
That's your
So I know
y2?
Yeah, so I put 0.1 for
X
x2, x, yeah,
e to the minus 0.1.
Yeah.
Times 1.1, right? Plus the 1.1 times the 0. Yep.
All right.
And then the first y was just 1 plus e to the, yeah, the first one is just 1.1. So 1.1, so the second one is this, the third one is that, and then y4 will be that plus 1.29953 e to the third x, which is minus 0.3 minus x times 0.1. So, and then if we do that, we will get 1.39388. Yeah. So those are the values of the y's using Euler's method, or approximating what the answers are going to look like. And we can use the explicit solution to find out. So the explicit solution for this is, yeah, the explicit solution is y equals e to the 1 minus e to the minus x. And so if we make a nice table here, yeah, and so this is going to be the approximation. And this is the exact using the explicit solution. No? So y1, here it turned out to be 1.1. And if we plug it into the equation, let's see. So that happened at 0.1. We get 1.09984 for the exact. And then y2, so this happened at, so this was when x was 0.1. So this is now at 0.2. Yeah, because x2 was 0.2. So our answer was 1.19953. And the exact will be 1.19874. And y3, the x was 0.3, and the approximation was 1.29774 using Euler's method. And here it's 0.3, 1.29587. And for y4, that's when x was
What's the
x3 is 0.3, yeah? Those are lagging by 1.
No, well, how do you, like, it's, for x3, it's, 1.1995 plus that times e to the negative what?
Say that again?
What do I put for y of x3, what is e to the negative what?
For y3?
Yeah.
X2.
All right. And what was,
the x is lagging by 1. So you're using the previous x to find the next y.
wait.
8.
Oh, yeah. Oh, right. Oh, right. Right. X just goes up incrementally. 0.1, 0.2, 0.3.
Mm-hmm.
Right. So the independent.
So these need to move by 1 because the original exact one is just e and this one was this here was 1. Okay, so we can find the error by just taking the difference between the exact and the approximate. So just to illustrate this, the error will equal to exact minus approximate. So, like say if we're trying to find the error 3, we just do 1.29. So basically it's the difference between the two answers. 9874, and that would be our error. So to get 0.099002. So that's the error at one of these values. And similarly, you can find the error at any two values.
Or the percentage.
Or the percentage error, yeah, by dividing by the exact and then multiplying by 100.
Well, yeah.
Any questions on that?